Hi girls, today we're going to start learning about probability. You've probably learned a few things about probability before, so our first job today is to try to remember everything that we already know about probability from our study last year or maybe in primary school. We have to remember the meanings of some words that are special to probability, such as event and sample space. And we're also going to revise how to calculate the probability of an event. So this will be a big revision video. So first of all, let's think about probability. What is probability? Well, we often refer to probability in everyday language when we say things like, oh, that's unlikely, or that's a sure thing. So I might say, for example, that it's unlikely to rain tomorrow. What I'm really saying is that the probability of rain is quite low. But that's a kind of relaxed way of thinking about probability. In maths, of course, what we try to do is actually calculate probabilities. So rather than just saying it's likely to rain or it's unlikely to rain, we try to work out exactly how likely or unlikely something is. So let's have a look at a bit of terminology. Here's a few words that you might hear as we discuss probability that you probably won't hear in this context in other places. So first of all, a random experiment. A random experiment is something which results in a list of outcomes which occur without interference. So just to give you a practical example of that, if I throw a die and record the outcomes that I get from throwing a die, that would be a random experiment. There's 6 possible outcomes and they're occurring randomly without interference. Tossing a coin would be similarly a random experiment. Choosing someone at random would be a random experiment. Sample space is another concept that you'll hear of, and sample space is the list of all the possible outcomes in an experiment. So thinking about the examples that we've just talked about, if I'm tossing a dice, then my sample space would be the outcomes 1, 2, 3, 4, 5, or 6. That's all the possible outcomes that I can get if I toss a die. If I toss a coin, of course, there would only be 2 things in my sample space, heads or tails. We don't count the coin landing on its side because the probability of that happening is so extremely small. Okay, so we know what a sample space is. What about this thing called an event? When we talk about an event in probability, what we're talking about is a particular collection of outcomes that we're interested in. So, thinking about the tossing a die, rolling a die, again, I've got a sample space of 1, 2, 3, 4, 5, 6. That's all the possible outcomes. But I might create an event that I call rolling a number greater than 4. So the outcomes that are in this event are only 5 and 6. So an event is a particular group of outcomes that you're interested in. What are some other examples? Well, I might say the event that I will toss an even number when I roll my die, or the event that I'll get heads when I toss a coin. Okay, so I'm hoping that those terms are clear now. Let's move on. Alright, if I want to work out the probability of an event, there's 2 things that I need to know. I need to know how many possible outcomes are favourable to the event. So if you think about my example, of the event of tossing and getting a number greater than 4, there are only 2 outcomes that were favourable to that event, and that's 5 and 6. On the bottom of the fraction here, my denominator is the total number of outcomes. So if you think about your sample space, the number of things in your sample space will be the total number of outcomes. Okay, let's do an example so you can see it in a practical context. We're going to look at the probability of getting an even number when I throw a die. Okay, so first things first, the sample space of throwing a die is going to be what? We use these curly brackets. 1, 2, 3, 4, 5, 6. There's my sample space. So there are 6 items in my sample space. What about my event space? So remember that the event is getting an even number. So which are the outcomes that are favourable to that event? 2, 4 and 6. 2, 4, 6. Oh, sorry, I missed my 4 somehow. So if I want to work out the probability, and we write it like this, probability of an even number, then that will be equal to the number of outcomes in my event space, which is 3, divided by the number of outcomes in my sample space, which is 6. So 3 over 6, which we can see is the same as a half. The probability of throwing an even number is a half. Okay. Probabilities are always between 1 and 0, and I'll tell you why. The probability of 0 means that there's absolutely no way that event can happen. And a probability of 1 means that that event happening is an absolute certainty. So let's think about it like this. Say I have a bag of lollies. All the lollies in there are Sherbies. The probability of me putting my hand in that bag of lollies and pulling out a Redskin is 0. It's not going to happen. However, the probability of me putting in my hand into that lolly bag and getting a Sherbie is 1, because there's only Sherbies in the bag. It's an absolute certainty. Just to note that probabilities can be written as decimals, they can be written as fractions, or they can be written as percentages. So I could say, of picking a Sherbie out of the Sherbie bag, I can say I've got a 100% chance, or I can say I have a probability of 1 that I'm going to choose a Sherbie. So this is something to remember. This here just means that all probabilities need to be between or equal to 0 or 1. So if you're doing a probability question and you get a probability of 1.5, you've got the wrong answer. If it's over 1, you've got the wrong answer. Now in class we went through these kind of categories and thought about examples for a 0 chance. That's like pulling a Redskin out of my packet of Sherbies. Low chance, even chance, high chance and certain chance. So if you're watching this video, it would be a good idea to have a go at this exercise. We came up with a probability of 1 was that we're all going to die, so that was a bit depressing. Probability of 0, embarrassingly enough, was that we would go to a Michael Jackson concert, because of course he has passed away. So see if you can come up with some in the middle there. All right, a little bit longer. One more thing that we need to look at, and that's this term here, the complement of an event. When we talk about the complement of event, it means the set of outcomes that are not in the event. So let's say we define an event A. I'm going to call it A because I get sick of getting an even number when you throw a die. The event A is getting an even number when you throw a die. Then the complement of event A is going to be the opposite of that, so getting an odd number when you throw a die. So you can see that another way of saying it would be to say the event A and the event not A. We could say not A, or the complement of A, and we use that little C there to indicate that it's the complement of A. And a useful thing to know about the probability of an event A and the probability of its complement, or not A, is that these two probabilities should always add to be 1. Okay, let's do 2 examples of probability and then we'll call it quits for this video and you can do some exercises. Let's have a look at this spinner here. The spinner is divided into 5 equal sections, and this question is asking me first of all to list the sample space. So we'll do that. What are all the possible outcomes? Use our curly brackets. Well, I could have a 1, I could have a 2, I could have a 3, I could have the other 3, or I could have a 7. So I write the 3 twice because there's 2 ways that 3 can happen. Alright, so the next question asks me to find the probability that I will get a 3. So the probability of the event choosing a 3. So let's remember how we calculate a probability is we say how many outcomes are favourable to this event. So outcomes favourable, in other words, how many 3s, and I'm going to divide that by the number of possible outcomes. Gone off the page. So let's have a look. What does that give us? Probability of 3 is equal to the number of outcomes favourable is 1 outcome here and this other outcome here, so it's 2, and I divide that by the total number of outcomes 1, 2, 3, 4, 5. So the probability of 3 is just 2 over 5. Let's have a look at C now. Find the probability of not a 3. So probability of not a 3. Well, how many ways can not a 3 happen? Not a 3 can happen here at 1. Not a 3 can happen if I get a 2. And not a 3 can happen if I get a 7. So there's 3 possible ways that I can not get a 3. So my numerator of my probability fraction will be 3, and the denominator is still the same as the sample space of 5. And notice that if I add these two together, 2/5 plus 3/5, I would get 5/5, which is 1, probability of 1. Let's have a look at probability of a 3 or a 7. So now, if I look at my event space, I could get a 3, that's favourable to my event because I'm looking for a 3 or a 7. I could get a 7, that's favourable to my event because I'm looking for a 3 or a 7, or I could get the other 3. So there's 3 different ways that I can get a 3 or a 7. So 3 over 5 is that probability. And probability at number at least 3. And let's say if it's at least 3, then that event includes 3, not 2 because that's less than 3, not 1 because that's less than 3, 3 again, and 7 because it's greater than 3. So there's still 3 ways that I can get a number that's at least 3. Okay, I think that's long enough for this vid. I'll do the other example in class. Just showing you your exercises. Whoa. The exercises for this lesson are exercise 9A, questions 1, 3, 4, ACE 5, 7, 10, 12 and 14. Good luck.